Hi everybody and welcome back. In this screencast I'm going to do things a little differently. Rather than introducing any new theory, I am going to introduce the Data Lab, which is really the first major lab that would require you to complete in CS224. I get a lot of questions about how to start this lab, so on and so forth. And as it is the first of these major labs, that's not surprising. So I thought it would be helpful just to put together this quick video showing kind of how you can get the lab and actually begin it and so forth. I'm not going to be covering the details of actually submitting your results in this screencast, but rather just how to get you started. So let's go ahead and jump in. So here I am just logging into my Ubuntu VM on my Windows machine. So you should have a very similar setup, so no surprises here. Give this a moment to start up. Any Dana. Okay, here we go. All right, so again, first of all, you can always access the labs and homeworks by going to the course wiki and finding the appropriate link on the left. So we're looking for labs, and we are interested in the data lab. So you see here we have the data lab write-up, the handout tar, and the scoreboard. So we want the handout tar file. This is going to provide for us all the source files and everything that we need to actually work on the lab. So if we click on that link, then we can download it. And I have downloaded it previously. That's why I didn't bother doing it again. So here I have it in my downloads folder. So I'm just going to go ahead and copy this and create a new folder to work on it. Just call it demo. So now I am pasting that tar file in the demo folder. Okay, so having obtained that tar file then, again, all I would have had to have done is clicked, but I did that previously. Clicked on the link here, but I did that previously. So I will now go to my documents folder, into the demo folder, and voila, there is the tar file. So I'll expand the file. Okay, which creates a new folder, Data Lab Handout. If we change directories into that folder, then we see a bunch of stuff. And so let's just real quickly take a look. We see a few C source files and then a couple executables, DLC and driver.pl. So it's nice. I have some color coding going on here in my terminal to show me that these two things are executable. But notice I can always look over at the permissions here. I've done an ls-l, and so I get the long listing for each of these files, and so I get to see, for instance, the permissions. So even if they weren't green, I could look over here and see these X's to indicate that these are executable files. This doesn't necessarily tell me a lot right out of the gate, but notice that there is a README file. We should do what it says. So I'm going to use the more utility to open the README file. More, well, I'll show you the difference between more and cat, for instance. If we just use cat, then the whole file is output to standard out, and I only get to see the last part of it. Okay, I'd like to see the whole file, so instead I'm going to use the more utility, which will put a page worth up on the screen, and then if I want, you'll notice down here in the lower left, it's indicating that I'm viewing, excuse me, 13% of the file. And as I hit the enter key, then it will scroll down through the file. So in the README then, we have directions to students, which would be you. Okay, so your goal is to modify your copy of bits.c so that it passes all the tests in btest, okay, without violating any of the coding guidelines. And we'll talk about those guidelines in a minute. So then they give us a listing of these files. So we saw these before. Let's go ahead and scroll up a little bit. So there's a make file. Now many of you will not have heard of make files. Basically what a make file does is it automates the process of invoking the compiler toolchain in order to create executables from our source code. And make files can be quite sophisticated. They can be used to build more than one executable, and they can be used to create rules so that we can build those executables in different ways. So why don't we go ahead and open another terminal and actually look at that make file. Okay, so if we say more make file, for instance, and we can take a look at it. Okay, a few things just to show you in the make file. You'll notice these rules here. So each of these rules has a name followed by a colon. All right, and I'll explain a little bit of the syntax. So if I were to type the word make, that would invoke the make utility, and it would look inside of the directory where I am currently working, the working directory. It would look for a make file with a capital M. And the default is to execute the first rule if I haven't given it a rule. Actually, I'll have to double check on that. I think the default is to execute the first rule. It could be to execute the rule called all. I'll have to double check that. At any rate, this rule, then following the colon on the same line, we have a list of dependencies. Okay, so this rule depends on the btest, fshow, and ishow rule, or targets, sometimes they're called. That might actually be the more appropriate title. I won't pretend to be a makefile expert, but the basic idea here is that so when we try to build all, we're going to need to build btest, fshow, and ishow. And here's btest, fshow, and ishow. Now, in the case of these targets or these rules, then we've also got a list of dependencies. So btest depends on these files. Why do we care? These are source files, and one nice thing about make is that it can tell when a file has been changed and when it hasn't. So if something hasn't been changed, then we may not need to compile it, and so we can set up our make files to actually execute more quickly if we've only made small changes to our projects. Okay, so we've listed here then the things that we need for btest to be built, and then on this next line there's a tab followed by a command to execute. So if we were to say make space btest, then we would be invoking this set of commands, or more specifically this command, which is dependent again upon these files or rules. In this case, they're all files. All right, then it looks kind of funky. Okay, so we've got this $sign and parentheses with cc inside of it. So you can think of these as variables. So cc is a variable that we set up here, or they set, whoever created this make file. And so here cc, which we're referring to our compiler, has been set to GCC. Okay, so what's going to happen then is that this will be evaluated to GCC. So we'll be executing the command GCC followed by, same thing here, there's this variable C flags. So these are then, so this C flags will be replaced with this text, this string here, which is setting some of the flags we want to set on the compiler as it's running. The same kind of thing is happening here with libs. Okay. Now you'll notice here there's the -o, which you may or may not be familiar with. This is telling the compiler, hey, I want to specify the name of the executable that you're going to create. Okay. And in this case, the name will be btest. So if we were to say make btest, it's going to create an executable called btest from this stuff. Now, it won't do that just because we've said that's what we've placed so far. We also need to list then, in this case, the source files that need to be compiled in order to create btest. So that's all there. So the point is that you could type from the command line gcc space -0 space -wall space -m32 followed by a space and then -lm followed by a space and then all this stuff. Okay, you could type all that at the command line, hit enter, and you get the same result as if you typed simply make btest. Okay, so I'm not going to go through that work, but hopefully you're getting the idea here. This is a lot to type, and if I can simply type make btest and get the same thing, that's a savings for me. Okay, so that's kind of the idea behind make files is to automate a lot of that work you'd have to do by hand otherwise. So not as high level and in some ways as powerful as some of the IDEs you may have worked with in some of your introductory courses, but make files are kind of where that kind of thing started, okay, automating the use of the compiler. So I just wanted to expose you to that. I'm going to jump out for now so we can hit Q to get back to the command line, and we may or may not use that window again, so I'll leave it open. All right, so back to this terminal down here. So there's the make file. We then see that there should be a README file, which we are reading, and then there's some descriptions for some of the other files. Now, The one we care about the most is bits.c. As they note, this is the file you'll be modifying and handing in. Okay. I'm going to jump down here. You can read through the other stuff. I don't want to do everything for you. But down here, you'll notice that DLC and driver.pl, these have been starred. They're important. This DLC is the rule checking compiler, stands for Datalab compiler. And driver.pl is the driver program that uses btest and DLC to autograde bits.c. In other words, so DLC will be used to compile our program and make sure that we're following the rules for this particular assignment. Driver.pl is a utility that will not only invoke DLC and compile our program for us, but it's also then going to grade the performance of our submissions. Okay. We've also been provided with some utilities. So if we were to type make all, I'll jump back up here. It looks like this is still visible. You'll notice up here fshow and ishow. If we type make all, these utilities will be built and we'll end up with the executables fshow and ishow. Let's just go ahead and actually demonstrate this. So again, here's the make file in this folder, and I'm simply going to type make, and so that's going to run this utility make, and it will then execute the make file that's in this directory. All right, so off it went, and we see that it has, let's take a look at our directory now, created a few new executables. So here we see, let's see, did we have btest before? Yes. No, we didn't. We didn't have btest before. Now we have, let me make sure that's true. I'm going to scroll up here. Actually, I can look down here, can't I? Yeah, we had btest.c. We didn't have the executable, so now we have the executable. And we also have these utilities fshow and ishow. And I'll just demonstrate those real quick. So for instance, if I want to execute ishow, I'll type /, meaning, so this / says I'm going to execute something or I'm going to do something in my current directory. It's saying the immediate path, if you will. We'll type ishow. If I just do this, then it gives me the usage for this. It says, okay, this is how you're going to use it. You're going to say .ishow, val1, val2, and so forth. So I'll go .ishow and 56. And this is cool, so it gives me a hex representation of that value. Gives me the signed and unsigned values as well. Okay, so I'm going to leave it to you to dig further into those. Please feel free to go in and look at the source code. These utilities are doing something similar to one of the things you're asked to do on the homework problems. Okay, so you might get some ideas by analyzing the source code there. All right, so I just wanted to point that out. All right, let's jump back to this bottom terminal and keep scrolling. All right, so it says important, carefully read the instructions in the bits.c file before you start. These give the coding rules that you will need to follow if you want full credit. Use the DLC compiler to automatically check your version of bits.c for compliance with the coding guidelines. And they go so far as to tell you how to invoke this. They say DLC returns silently if there are no problems with your code. Otherwise, it prints messages that flag any problems. Running DLC with the -e switch, I give the example, causes DLC to print counts of the number of operators used by each function. Okay. Once you have a legal solution, you can test it for correctness using the btest program. Okay. Then they go on it goes on to talk about testing with btest and so forth. So let's go ahead and actually walk through parts of this. Like I say, I just want to get you started, and I don't want to save you from needing to read and understand on your own. Just wanted to give you a feel for this. So let's come back up here again. Look at our directory. So we have here the make file, and we ran the make file. But let's actually then run the DLC compiler on our source file. Now let's come over to the right here for a second. I'm inside of this folder, and I'm going to double click on the bits.c file, and by default I'm going to get gedit, which will open up this file so I can read it. So this is the bits.c file that you are provided. So there's already some source code in it with some useful comments. This is C code. You'll notice it looks very much like C++. That's not an accident. You'll simply note that it's missing classes and things like this. Should point out, let's see here. Okay, so how does this work? Well, sorry for scrolling around on you a lot. I was looking for something. You'll notice that we have a set of functions that look pretty kind of boring, right? So bit and returns to true, returns 2, get byte returns 2, and so forth. So each of these functions is really just kind of a template or a placeholder for you. And you need to come in and complete each of these functions so that it returns the correct value that meets the description up here. So a bit and, for instance, we need to return the value x and y. That's a bitwise and there. Using only, and then in this case we're given negation and the OR, the bitwise OR operator. That's all we get, okay? And we need to figure out how to use those in order to get back a bit and. We're given a maximum number of operators that we can use, which is 8. And we're given a rating, which is kind of like a difficulty rating for this problem. And that is how the number of points a portion of this problem is also determined. Okay, so this file is actually already syntactically legal, a syntactically legal C file. We can compile it. There's a lot of stuff here that you need to read through before you start this lab. There are details you need to know. I'm going to move on from this point. If you want to pause and get to that point, that's fine. I'm going to assume you've done that. I'm going to assume that you're going to do that reading and move on with the rest of what I want to show you. Okay, so again, I mentioned that this file can already be compiled. So let's see if I can remember how to invoke the compiler here. So we'll go --DLC, and then we'll want to provide the name of the program or the file we're trying to compile, which is simply bits.c. Okay, so this compiled and it didn't give us any errors. It did give us a warning. If we type the same thing, but we include the -e flag, then, which this is probably what you're going to most often want to do, we'll not only get the compilation, in this case we're getting a warning. I think that comes down to there being something not being used, which isn't surprising because we haven't completed the project. But what I want to draw your attention to is each of these lines is showing then a count of operators for the particular functions that we've written. So you can kind of see your score in terms of the number of operators you're using. We're getting a 0 everywhere because we're not using any operators. That sounds pretty good, except that our solution currently is not correct. And we can verify that by using the btest program. Let's see, I believe btest will automatically, okay, try to build and run our program and run tests on it to see if our functions work properly. So you'll notice here at the right out of the gate, it's like maybe I need to slide to the side here. Let's try that again. Yeah, now we can see a little better. So if I scroll up, you see right out of the gate that test bit and, okay, it failed. And what did it fail on? Well, it failed on these arguments that were given to it. It gave back 2, which isn't surprising. That's what it's hardwired to do over here. And it should be giving back this value. Okay. We also, this is cool, they provide for us the hex representation of the value. So you can look at that and have an understanding then of what the bits of that particular variable actually look like. And so it's run through and tested each of these, bit and, get byte, logical shift, bit count, so forth, and all of these things have failed. Okay, so there are really 2 things we're looking for. One is we want to successfully compile our program without any errors. Okay, and so we do that with the DLC compiler, which is going to verify that we followed the rules. We can use the -e flag to see how many operators we've used. But that's only half the battle. We need to make sure that we pass the tests, and so we'll use /btest to automatically check that for us. Okay, these are the things, the major tools you're going to use for the first part of this. We'll talk about submission a little bit later. but not in this video. Okay, so I just thought you're going to love me. I'm going to actually give you or work through one of these just to demonstrate how all of this changes. So let's go ahead and do the bit and function. All right, now we're trying to do a bitwise AND of the bits in these two variables. How are we going to achieve that? We only have negation and OR. Now, in order to do this, we're going to need to think, how can I accomplish AND using negation or not and OR? And hopefully it's coming to mind that, wait a minute, I can use De Morgan's laws, right? So if I am using the OR operator on two things, like I'm saying A or B, that is equivalent, okay, to doing the negation of the AND operation on it. See if I'm wording that right. So A or B is equivalent to, no, I'm screwing this up, aren't I? Forgive me. Let's just write this out. This will make more sense if I write it out. So if I'm trying to do A, and I'll use the logical operators here for a minute. There's a relationship between A and B, and A or B. It is not that they are equal. So what I'm writing here is not true. I can't see. Where is my vertical line here? There we go. Actually, that's not it. Sorry. I cannot see my keyboard. Just a moment. There it is. Okay. Technical difficulties. Okay. Got it. All right. So A or B. Okay, this is not true. These two things are not true. However, there's a relationship between the negation of A, logical A and B. Actually, I meant to say this. That is that the negation of A and B is equal to not A or not B. Okay, so this should be cluing us in a little bit here. So we have a bitwise negation and we have this OR operation. I'm showing you De Morgan's laws in terms of the logical operators. We don't want logical operators, we want bitwise operators, but this should be giving us a hint. So let's think about it for a minute. I want to talk about A and B. Well, bitwise A and B would look like this. And it is, of course, not equal to the bitwise OR of A or B, but the negation of A, excuse me, typo, the negation, bitwise negation of A and B is equal to the negation of A bitwise OR with the negation of B. Because what we're doing there then, when we're doing these bitwise operations, we're doing them bit by bit. And so for each bit, this is true. If we thought of each bit as a single value and we were doing applying the logical operators to them, this would hold. So when we do the bitwise operators, they hold, because in each case then we could think of bit 0 for A ANDed with bit 0 for B. Well, the negation of that is equal to the negation of the bit 0 in A ORed with bit 0, the negation of the bit 0 in B. Make sense? Now, of course, we don't want the negation of A and B. We want of A bitwise ANDed with B. We want just A bitwise ANDed with B. Well, this would give it to us, would it not? So if we negate both sides here, then we should have what we want. Okay, so we're not working with A and B, of course. we are working with x and y. So let's go ahead and try to code this up. So we can't use the AND operator, so we're trying to do something that's equivalent to what that would have been. So we're going to say then the negation of the negation, bitwise negation, return the negation of the bitwise negation of A, bitwise ORed with the negation of B, bitwise negation of B. And of course, all of this stuff is just me trying to reason out loud. Let's get rid of that. Save this, and let's see if we can compile that. Okay, so it compiled. Oops, I've got a couple errors. Undeclared variable A and B. I must have, oh brother, I'm sorry. A and B. I meant X and Y. There. Okay. Now this should compile. Sure enough, compilation successful. Again, there's that one warning we're not going to worry about for the moment. And actually, now I think I'm recalling that warning is something we all just have to ignore. And here we see now up here on bit and I'm using 4 operators. Now let's see if I'm actually doing it right. So now we want to run btest and scroll to the top. Okay, and it says error, test bit and has failed. We're returning a -2, and we should be returning this. Well, now wait a minute. Let's look over here. I'm not returning a -2. What's going on here? Well, what's actually going on is that btest isn't actually rebuilding everything we need it to rebuild, or it's not actually working on everything rebuilt. So we actually need to clean up our directory here. So we'll go make clean. All right. And now we'll run btest again. So when we ran make before, we built btest. And so the btest we just ran was based on the old source file before I made these changes. So if you've made changes and then you run btest and you don't see anything change in your results, it's just happened here, that's a pretty good clue that you need to clean out everything you've built and rebuild btest. Okay, so if we type make clean, you notice that one of the things that command causes to happen, that build rule, is that we do this rm-f star.o btest, so on and so forth. So we just got rid of the old btest. Now we'll do a make, and we just built btest again. All right. Oh, yeah, so here's the source of our warning. There's this errors thing set but not used. So we're not going to worry about that in this case. All right, so now if we run btest, look at the top, look at that. Now instead of getting an error, we're getting a score on our btest function. We get a score of 1, a rating of 1 with 0 errors. All right, so this is what you're going to be expected to do, or part of it. Please make sure you read all the way through the README, read all the way through the instructions in the source file. That'll put you in a situation to be able to complete the lab. I just wanted to get you started and show you some of these things, some of these utilities, remind you how they work, and show you a couple of gotchas along the way, such as needing to clean, do a make clean and then a make. I do want to draw your attention to one thing that personally tripped me up a little bit, and that is that, I'm trying to see where they say it here, you get to try to find it here. I'm not seeing it. Well, I'm not going to waste your time looking for it, but you are allowed to assume, it's one of the rules. Oh, here we go. You may assume that your machine uses 2's complement 32-bit representations of integers, performs right shifts arithmetically, and that it has unpredictable behavior when shifting an integer by more than the word size. So you'll need to think about how to handle that if you need to shift by the word size or more. Those 3 things can make your life easier if you realize them, especially this one, that you do get to assume that the integers are 32-bit 2's complement signed representations. Okay, I'm going to leave it there. I wish you luck. On top of that, I actually do wish you a little bit of fun. This will be a rewarding exercise, but I also hope that it's fun. You have this objective to not only complete each of these functions within the number of ops, but there's this added incentive to actually do it in fewer ops. All right, and we'll explain a little later how you can go about, actually I think it's in some of the stuff you'll read here, how you can actually compare your solutions to the solutions other people are getting as well as mine. So on the scoreboard that you'll have access to, my solution will be up there too, and so you can try to show me up in this. I encourage you to do so. It'd be great to see people do better. All right, so I'll stop there, and until next time, thanks.